The first thing I want to do is to thank Jeff Clements for a great presentation, and let's go to mine, which is the interactive effects of sediment buffering and predator exclusion on recruitment of commercial intertidal bivalves in northern Casco Bay, Maine. These are results from field experiments that were conducted there from 2014 to 2016. The state of Maine has 8 counties of the 16 that are coastal, and soft-shell clams are commercial in all 8 counties. The Maine soft-shell clam landings have kind of been up and down, ebbed and flowed over the course of the last 50 to 60 years. And we can see that from about 1980 to right now, soft-shell clam landings have continued to decline. In fact, in 2017, landings were at the lowest, and since 1977, statewide clam landings have declined by about 82%. The work that I'm doing has taken place in Cumberland County in the southern part of the state, and in fact, the area is in northern Casco Bay in the town of Freeport, which is most known for its LL Bean store, but it's also a mecca for soft-shell clam. Historically, clams have been landed there for many, many years. And around 2012 was a kind of a peak year of about $1.3 million. But since 2012, soft-shell clam landings have declined in Freeport by about 60%. And whereas clams typically are harvested throughout the intertidal, from the low to the mid to the high, most of the harvesting now is occurring only in the upper intertidal zone. So we asked what are some of the possible causes of the decline of clams in Maine. And so we've come up with about 11 different possibilities, from overharvesting to underharvesting, from disease to ocean or coastal acidification, the lack of sufficient spawning stock or the lack of sufficient numbers of clam settlers, coastal pollution, predation, loss of habitat, harmful macroalgal blooms, or combinations of these or other factors. So there's certainly a variety of hypotheses that could explain the decline of clams the decline of clams in Maine. In 2015, Friends of Casco Bay issued a report that had followed for many, many years, about 13 years, a trend in pH at some of their sentinel sites in Casco Bay, and certainly it was trending in the wrong direction. Coastal acidification, or pH, was certainly going down through time. So the other thing that they did was to interview clammers who had been clamming on a variety of different flats in and around Casco Bay, and it seemed that the ones that were no longer productive had pHs below around 7.5, and those flats that were more productive were above 7.5. So they decided that that was a link then between sediment acidification and clams, clam landings or clam productivity. But that was basically circumstantial evidence, and so we asked whether that link between acidic mud and clam flats, where it's no longer profitable for clammers to harvest shellfish, whether that link was real. And if it was, is it possible to adapt to the changes in sediment pH by adding crushed shells to help increase pH levels? Shell hash has been proposed by several as an adaptive strategy to increase pore water saturation state. And what we would do then is to increase the amount of shell that's on a flat in the form of calcium carbonate to see if that will actually buffer and enhance soft-shell clam settlement. That was proposed by Green in 2009. It was also a strategy that was identified by the Maine Ocean Acidification Task Force in 2015. So we're looking to see if it's possible then to mitigate sediments that are low in pH to see if we can improve recruitment of soft-shell clams. We asked then what was the relative importance of low pH sediments versus predation in regulating soft-shell clam recruitment, and can crushed clam shells lead to an enhancement in soft-shell clam recruitment? Again, our studies are in the Freeport area, and what we did was we went to 5 commercial sites and took pH early in the spring and chose the site to study that had the lowest pH. This is a box plot of the pH measurements that we got from the 6th to the 8th of May in 2014, and the average pH at one of the sites called Staples Cove was significantly lower than the other sites. So that is the site in which we set up our shell hash enhancement or buffering study. So that was Staples Cove, and this is 2014. We had 6 treatments. The treatments were arrayed in 10 by 10 plots where we had open controls and netted controls. And then we had 4 different treatments that included shell. 2 of the treatments included shell with 13 pounds added to the sediments on the top of the sediments, and 2 of those had shell that were added at double that rate. The shell treatments were either in open plots or in netted plots, and the netting that we used had an aperture of 4.2 millimeters, or about 1/6 of an inch. The shells that we used had been weathered for over a year, and they were soft shell clam shells that we crushed by simply walking on the shells to produce a shell that was between about the size of a dime and the size of a quarter, and these were then simply broadcast into the 10-foot by 10-foot plots. This is an example of a plot that doesn't have nets, but with 26 pounds of shell. This is one plot that has the netting and the 13 pounds of shell, and you can see that the netting actually has 2 styrofoam toggles that are underneath the net, so that at high tide the netting will kind of buoy up, so it won't interfere. If there are any clams that settle there, it won't interfere with their feeding. Here's a net that has no shell at all, so it's our control net. The design that we used was a randomized block design with 2 factors: shell at 3 levels, so no crushed shells, or 13 pounds of crushed shell, or 26 pounds of crushed shell. The other factor was netting, where we had no nets at all, or we had the nets. And we took 5 benthic cores from each plot at the end of the study. So that would be 5 times 30, or 150 cores that we took. And then we sieved each one of those cores on a 1 millimeter mesh. And we were looking for Maya arenaria, but in 2014, we also got mercenaria, the northern quahog. In 2014, we looked at the time that we were going to sample those plots in November, there wasn't any difference in the treatments between shell or no shell, or between netting or no netting. What we did find was that the pH had actually risen to levels of around 7.72. That was the average, which was significantly higher than what we had at the same location that we had taken earlier in May at 7.09. The results for soft shell clams showed that there was no significant effect due to the nets, nor was there a significant effect due to the shell. We use a p-value, or a probability value, to assess objectively whether or not the means are significantly different. P-values that are greater than or equal to 0.05 give us a non-statistically significant result, and p-values less than 0.05 mean that the treatments are statistically different. For Maya arenaria, soft shell clam, once again, we found no netting or no effect due to shell. For mercenaria, the hard clam, we did find that shell did not make a difference. That is to say, there was no significant difference due to the presence of the shell, but that the netting increased the recruitment of mercenaria by about 44 times compared to the no netting treatments. The sizes of the clams that we found for soft shells were between 2 millimeters and about 19 millimeters. For the hard clam, mercenaria, the sizes were from about 2 millimeters to about 7 millimeters. In 2015, we repeated the same exact study at 2 other sites that once again had the lowest pH among 5 or 6 sites that we sampled early in the spring for pH. So again, we set up the same study, and this is the results for the pH in October after about 160 days after the experiment had been initiated. And what we found was that this Winslow Park site, that pH was actually lower in the netted plots than it was in the open plots, lower pH in the netted plots. We found at that site that there was approximately 70 times more clams in the netted plots at the end of the experiment than in the no netted plots. And once again, the presence of shell didn't make a statistically significant difference. The netting was statistically significant. At the other site, Little River, we found the same pattern with pH, in that the pH was lower in the netted plots, but once again we found that there was an enhancement of softshell clam recruits in those netted plots, 23 times more softshell clams in the netted plots than in the non-netted plots. We didn't find any mercenaria in 2015 at either one of these sites. There's what I call a logical flaw in the design of the large-scale study. That is to say, the addition of substrate to the intertidal could also do something besides buffer. And so the shell hash may protect small clams by making it more difficult for predators to search and consume their prey. Also, the shell could act in a different way, in an opposite way. It may actually protect small crabs and other consumers of clams, making the settling and juvenile prey more susceptible to predators. So what we did was a small-scale study in Staples Cove in 2014, and in the other two sites in 2015 at Winslow Park and Little River, to look at additional treatments. In 2016, we did not conduct a large-scale study, but we conducted another small-scale study. So I'm going to talk about the 2014 and 15 studies first, that included 8 treatments where there were 10 replicates of each. So there's a control with no netting, a control with netting, a layer of shell on top of the ambient sediments and no netting, a layer of shell on top but netting present. Then we had limestone chips on top of ambient sediments without any netting, chips on top of the sediment with netting, and then granite chips on top of ambient sediments and granite chips with netting. The granite chips are a habitat like limestone and shell, but that doesn't buffer any sediments. And we did these using plastic plant pots. These are 6-inch plant pots that we pushed into the sediments and then added these different treatments. And if we were to look at the study from above, we would see a completely randomized design with shell, control, limestone, and granite in both opened and protected experimental units, or these plastic 6-inch plant pots. The netting was exactly the same aperture as the netting that we used in the large-scale study, 4.2 millimeters. For the small-scale study results, what we found was that there was nearly a doubling of clam recruits in the netted plots, but that there wasn't a habitat difference, or crushed shell didn't really make any difference. In 2015 at Winslow Park, we found an enhancement of clams due to the nets, but once again, not due to the presence of the habitat, which included the crushed shell. 4 times more clams settled in the netted plots versus the no netted plots. At Little River, we found no significant effect due to shell or due to netting. So the summary of those 2014 and 15 buffering experiments on both the large scale and the small scale was that there was no significant effect due to the presence of shell or additional substrate. In 2016, we were advised that the substrate that we used as our shell hash may have been too large to actually buffer very well. So what we thought about then was to decrease the size of the shell and see if increasing the surface area of the shell hash would make a difference. So once again, early in the spring, when we started the study, we looked for sites that had the lowest pH, and we found two, and those two were Little River and Recompense. And once again, we used these plastic plant pots and used ambient sediments as controls for both opened and netted. And our treatments were large shell that was about a little bit larger than a dime. This was similar to the shell that we had used in 2014 and 15 in both the large and the small scale studies. In 2016, we added shell that was smaller, 5 to 10 millimeters in size, and then finely ground shell that was 1 millimeter. So we used all of these as separate treatments. And then we also protected them. So you're looking at 6 treatments right here. In addition, what we did was we used a shell flour that was made out of Crassostrea gigas shell that we sieved to 1 millimeter. And we also protected that with netting. And then the final treatment was granite, like we used in the first 2 years, and also granite with protected. So there's actually 12 treatments, and we used 10 replicates of each of those treatments at both Little River and Recompense. This is putting out the experiment in April of 2016 and April of 2016 at Recompense. And there's a shot of what the plant pots with the various treatments might look like. The sediments were measured by Mike Doan from the Friends of Casco Bay using this particular pH meter. And through time, what Mike showed in the ambient sediments outside of the plant pots was what was happening on the flats with pH through time. And as you can see, from about the 1st of June, when soft-shell clams are settling, to the end of October, that the pH is actually trending down and that it's less than 7.5 in the ambient sediments. At the end of the study, now this went from April 6th and April 5th and 6th, 2016 to October 25th and 26th, 2016, at Little River, we found a decrease in pH with the netting, as we had in the large-scale studies. At Recompense, we found the same thing. So if we combine the information here and look at both of the study sites, what we're seeing is that in the netted plots, once again, the pH is lower than it is in the open plots. And what we think is that's a function of respiration, because there's probably more life underneath the netting because they're protected from predators than there are in the open plots. But the point is that the nets have a lower pH than the open plots. For soft-shell clams at Little River, we found no effect due to the presence of shell or to the presence of netting for soft-shell clams. So neither netting nor crushed shells made a difference. And we found the same thing with hard clams. Netting made no difference, but neither did shell. At Recompense, we found that netting made a significant difference for soft-shell clams, an enhancement, and for hard clams, we also found an enhancement due to the netting, but no shell effect. So if we look at everything, we conducted 2 large-scale studies from 2014 to 15 that showed that link between acidic mud, or the potential link between acidic mud and soft-shell clam production, wasn't real, at least in our study sites, and that the addition of crushed shell didn't result in a significant enhancement of either Maya or mercenary recruits. Similarly, the 3 years of the small-scale studies also showed that there was no link between the acidic mud and soft-shell clam or northern quahog production. Soft-shell clams actually recruited more heavily in netted large-scale plots and in netted small-scale plots, regardless of whether those contain shell or other potential habitats. And also that those netted plots had lower pH than the unnetted plots. So at this time, there's no really good reason for communities or others to spread crushed clam shells on the intertidal to attempt to enhance the numbers of juvenile clams. And as an independent test of the effects of low pH sediments on clam recruitment, we've placed what we call clam recruitment boxes, which is just a 1 foot by 2 foot by 3 inch deep box constructed out of wood and protected on the top and the bottom with a fine mesh screen called PET screening. And we've placed these on intertidal flats in and around the Harpswell River in Freeport in low pH mud in the spring and sampled them in the fall. This was in 2015. And what we found in these boxes, along with sediment that filtered into the boxes or settled into the boxes, was soft-shell clams, 9,000 per square meter or 32,000 per square meter. So we really think that the pH of the sediment, although it's low, is not regulating soft-shell clam populations, but rather predation is regulating those soft-shell clam populations at the present. And we want to thank Jeff Robinson and Hannah Miller. The funds were provided by the Maine Economic Improvement Fund for Small Campuses to the University of Maine at Machias. Thank you very much.